back to Scale Me Down. Please like and subscribe to support the channel. And in previous videos you've seen us 3D print many things, but never an entire model aeroplane. This will be our first attempt, and it's an Avro Vulcan bomber produced by Dominic J. Sturrock Green, and I'll put a link in the description below as to where you can download the STL files for yourself. It should make a nice stablemate for the Avro Lancaster bomber that we reviewed in a previous video. To print this at home, an inexpensive 3D printer such as an Ender 3 will do, and we are going to use our CR10S. Let's have a closer look at the design.
The design is printed in a number of parts. Most take around an hour to print and some are an overnight job. It's assembled with cyanoacrylate, Ca glue.
When you download your STL files to make the 3D printed parts, you also download these PDF instructions to print at home, including the decals at the end. However, the instructions send you to planeprint.com to set up your 3D printer for thin wall printing that's required to produce the parts for this model. There's not really a lot of workshop skills or mess required to produce this aircraft, but there is a bit of finicky setup required to set your printer up to produce the parts. Planeprint.com have a full set of comprehensive videos on how to do this, and they get you to make these little test prints, these small wing sections, which are free to download, and it shows you what to tweak with different results. However, one of their settings was to do with something called surface mode, and we couldn't get many of the parts to work properly using this setting, as the end of the tail cone and nose cone and such was missing. So in the end we turned that off. All up, with on and off printing, this took almost a week to produce all the parts to make this model.
This is that surface mode I was talking about. If you print your own, you might need to turn this off. The plans cost £10 and it costs just less than £20 in plastic to produce, so the airframe is very reasonable in terms of cost.
The design requires one of these inexpensive FMS 50mm fans, and it's very clever as the intake ducts are bifurcated down to the fan, and then the fan exhaust passes out through the 4 jet nozzles in a scale-like manner. And to finish the model, in addition to the fan, you're also going to require a small amount of carbon fibre tubing, 2 9-gram servos, a speed controller and a receiver.
Right, it's time to glue it together then. I made sure that the mating surfaces were all dead flat for a strong, accurate joint. I then glued the parts together using medium cyanoacrylate, Ca glue and activator, aligning the parts carefully as I went. There were 1 or 2 holes to open out, which I did with the Dremel, and also some bits to clean up with a file. I joined these parts while slid onto the spar so that they aligned perfectly. The only fiddly bit really was threading these pull-through strings through these 2 fuselage parts. It would be very difficult to get these through afterwards. These will pull through the extension leads for the elevons to the receiver. Other than that, the model is quite easy to assemble. Just take your time aligning the various bits, as the walls are very thin at 0.4mm. Also, don't forget to connect up and check that your fan works before fitting these pieces. Time for a splash of paint. I just used what I had lying around really. This sea grey colour was a tin of primer, and then the dark green was a Tamiya olive green. We chose this paint scheme because the top and bottom colours are different, which makes it easier to work out which way up the aeroplane is. And we chose the registration XH506 that appeared in the James Bond Thunderball film.
So here we are, all finished and with a splash of colour. It took a few hours to put it together and paint it like this, but it was a fun and easy job to do. And what's interesting to note is just how the elevons work, and you'll see here that it's only the inner portions that are driven by the servo, and that the outer portions are driven by a small carbon fibre connecting rod.
But more importantly, does it fly? Here my dad, Chief Launcher, gives it the heave-ho. Initially we were a little worried about the launch as it's not the easiest of things to grip. However, it got away easily, as you could see, particularly as it was helped by this 8 mph headwind. On this 3-cell setup it's certainly not overpowered, but there is enough, and I think it sounds quite realistic and jet-like. Time to test the stall, and as you can see it's a complete non-event. Very easy. For this, the maiden flight, these battery packs were brand new. The 1300 mAh, and the flight was just over 3 minutes, leaving 30% left in the batteries. She's certainly very pretty and looks every bit the Cold War nuclear bomber. Of course, on our CR10 Max bigger FDM 3D printer, we could scale this design up by about 40%, and that would then fit the FMS 70mm fan. Food for thought.
That's uniform, stay back up here.